All right, here we go, geometry students. This is the continuation of the Geometry Common Core Regents exam for January 2018. This is another Regents review video. Once again, January 2018. Again, this is not a challenging exam, in my opinion. Could be hard for you. I hope it's not, though. So these are just going to be the solutions. That's not blue. These are going to be the solutions to parts 2 through 4 of this exam. These are the open-ended short response questions. Actually, they're not short. It depends on the part that you're in. But these are the open-ended response questions that require for you to show your work and expertise in the field of geometry. By the way, this is the January 2018 exam. I said that several times. But what you probably are not aware of yet is that they finally, the New York State Ed Department finally removed one of the part 4 questions on this exam. So if you look at like previous Regents review videos, the very, very last part of this exam always had like 2 very challenging questions. Now they just have 1. And the question on this exam, the part 4, was so not challenging. It was a walk in the park, easy stuff. I was shocked when they put that on there. But we'll see that later in this video. Do not cheat off of this section. I know for sure that people love to cheat on the part 2s, 3s, and 4s because they want to get the answer quickly. But the problem is that, you know, these answers are actually public in like the model response sets that the state releases. But still, just don't freaking cheat. You need to do well, people. You need to do well on this exam. It just makes you look good, right? I mean, it shows that you know some stuff about certain things. You might not use it again, but you still know geometry, right? So don't cheat. Just don't do it. Make sure they hit that subscribe button down below. Consider becoming a patron on my Patreon page and visit my website at www.nysmathregentsprep.com. Yeah, I talk very, 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 very fast. Both those links could be found in the description below. And becoming a patron helps me out a lot. Keep the channel going for a very long time. And my website just has so many math review stuff content on there. And you might find useful. And I use the TI Inspire CX calculator. That link could also be found on my website. The link is in the description below. This is such a powerful tool. I usually don't, I don't use it often in geometry just because some of the calculations are just so simple. But in like Algebra 2 and Algebra 1, but you already took that. In Algebra 1 and 2, so useful. All right. That's enough advertising for today. Number 25. This is the Part 2 section first. So, we're given that a parallelogram ABCD with diagonal AC is drawn. We're trying to prove that these 2 triangles are congruent to each other. Ladies and gentlemen, there are 4 ways you could prove these 2 triangles congruent to each other. You could prove by side, 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 angle, side, angle, side, angle, 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 side. You cannot use hypotenuse leg for this because it's a parallelogram. We don't know that the angles are right angles. So, for the sake of this video, I'm going to prove it only by one way, which is going to be side, side, side. You could use side, angle, side. You could use angle, side, angle. You could use angle, angle, side. I'm not going to do that because it's a little bit more work to do. So, a couple things about a parallelogram. It's a parallelogram. We know that the opposite sides in a parallelogram are congruent. So, this side's congruent to this side's congruent to this side. And for the final side, AC is reflexive. Let's do it. Here we go. Number 1, I'm going to say the given information, that parallelogram ABCD with diagonal AC, which is drawn. Your reason is given to you. Number 2, I am now going to say that the opposite sides are congruent. So we're going to say that AB is congruent to, oops, that's a horrible congruent symbol. AB is congruent to CD, and that AD is also congruent to CB. Those are the opposite sides. So your reason is in a parallelogram. Opposite sides are congruent. Sweet. So we know that for sure. Okay. Number 3. I am now going to say that line AC is congruent to line AC, and your reason is the reflexive property. That's good. And number 4. Finally, we just proved by side, side, side. So now we're going to say that triangle ABC is congruent to triangle CDA. Your reason is side, side, side is congruent to side, side, side. And just to end your proof, this is my new thing that I'm doing now because I am in college when I'm doing this. When I was in high school, I always put like QED. You could even draw a little square to end your proof. You could do that, or you could do QED, which just means to end your proof in Latin. In Latin, it's pronounced quod erat demonstraten, means to be demonstrated. But you don't need to do that. But it's just always fun to do, little nerdy things, because like on the Regents exam, like you need to like take a mental break somewhere, right? Because you can't just be doing math the whole time. So it's always nice to like lighten the mood a little bit. I like to put smiley faces on my paper too, but you do what you want to do. Again, you see, I like to talk. Okay, that's how you do the proof. Number 26. Okay, this is a construction. Real quick, I do the software computer demonstration of the construction. I also go to a hands-on construction. If you want to see the hands-on construction, just fast forward just a little bit to see that construction. If you want to see both, by all means. If you just want to see this, that's fine. Whatever you want to do, you want to do. Here we go. Number 26. The diagram below shows circle O with diameter AB. Using a compass and straight edge, construct a square that is inscribed in circle O. Leave all construction marks. So I need, first and foremost, I need a compass and I need a straight edge. I need this to be a little bit smaller. There we go. Okay, so I need all this, all these tools. Okay, so the first thing that you want to do when you inscribe a square is first draw yourself a diameter. Well, it's already given to you, so that's good. So in order to construct the square inscribed in a circle, you're just going to place your compass point on one of the endpoints of the line segment, in this case, point A. You're going to extend a little bit more than halfway, passing a little bit past point O, so a little bit more than halfway of the line segment. And you're going to swing above and below. Just create one continuous arc just above and below. It doesn't have to be a full circle. And then I'm going to place my compass point on B and do the exact same thing. So from here, we have 2 intersection points. So now what I'm going to do is I'm just going to take my straight edge, place it right on these 2 intersection points. Let me zoom in a little bit. Place it right on these 2 intersection points and simply construct your line just like that down there. Now we're not done yet. All we just did is create a perpendicular bisector. We didn't do anything yet. Well, as you can see here, I have an intersection point up here and up here that's on the circle. Okay? So now what I'm going to do is I am then going to take my straight edge again, but I don't need to because I have some tools that make it straight. But you should take your straight edge and just place your straight edge on the intersection point and draw yourself your square, connecting all vertices shown here. Okay? I should change the color just because it's all the red stuff. Let me change it to, I guess this color. That'd be nice. Yeah, okay. So here's my square. Okay? And that's all you do for that construction. All right? And that is how you do this construction. Again, I'm just going to jump right into the hands-on construction if you want to see that. If not, then continue on to question number 27. All right, here's the hands-on construction for the Geometry Common Core exam, January 2018. This is question number 26. Once again, the diagram below shows circle O with diameter AB. Using a compass and straight edge, construct a square that is inscribed in circle O. Leave all construction marks. So what we have to do is determine if we have a diameter, and we do. If we didn't have a diameter, we would have to construct one. So what we're going to do right now is place your compass point on A. Extend your compass a little bit more than halfway of point O in order to create a perpendicular bisector. Once you have that, we are going to swing above and below. And that is how I just created that whole arc. And repeat the process on point B without changing your compass setting. Just like so. Now that we have this, we're going to take our straight edge and simply connect these 2 points. Now that we have these 2 intersection points on the circle, these are our new vertices of the square. Okay? So now from here, all we do is simply connect these intersection points to our given points A and B. And once we do this, we have our inscribed square inside of circle O. And that, ladies and gentlemen, is how you construct the square inscribed in a circle. And that is how you do question number 26. Okay, here's question number 27. Given that right triangle ABC with a right angle at C, if the sine of A increases, does the cosine of B increase or decrease? Explain why. Honestly, this was, I think, in my opinion, the hardest part 2 question on this Regents exam. It's just confusing. It's confusing. Here's the deal. If you said that if the sine of A increases, that the cosine of B decreases, I'll explain your confusion down the road. But I'll tell you the answer right now. And then I'll explain, of course. If the sine of A increases, then the cosine of B must increase as well, since the sine of A is always equal to the cosine of B. So if you just stated that fact and you said that cosine of B must increase as well, you got full credits. Now, honestly, since if you put since sine of A equals cosine of B, that's technically explaining your answer, even though it's very short, but that is your answer. Now, of course, I'm not just going to leave it there. I need to explain why. You know, it's my job, right? So here's what you could do. You could provide an example. I personally provided an example on this answer key that I made. So here's an example. Suppose you have the sine of A equals the square root of 2 over 2. Okay? If the sine of A equals the square root of 2 over 2, then the cosine of B must equal to the square root of 2 over 2, since, again, the sine of A is equal to the cosine of B. All right? Now suppose that the sine of A increases to the value of radical 3 over 2. And I'm just going to put in parentheses, since radical 3 over 2 is greater than the square root of 2 over 2. Okay? Then the cosine of B must increase to the value of radical 3 over 2 as well. Again, by the same reason, since the sine of A is equal to the cosine of B. So, simultaneously, the value of cosine of B increased. So, that's just an example. Now, here's your answer, right there. Now, what if you put down that the cosine of B is decreasing? Well, let me show you where you kind of messed up a little bit, okay? You got confused with the letters. You didn't get confused with the function. You got confused with the letters A and B. Let me tell you why. Suppose that the letter A is equal to 60 degrees. Now, sine and cosine are cofunctions, which are complementary. So you were probably thinking, oh, well, if A is 60, B is 30. Or, you know, you can pick any number. Just, I mean, you add them up together, they must equal 90 degrees. But, you were probably thinking, oh, okay, well, if this is 60 and that's 30, that's fine. But what if you increase the A to 70? That has to decrease to 20. So that might be a confusing topic for you. It's not asking you for what happens to B if A increases. It's asking you for the whole function, the sine of A and the cosine of B. It's not asking you for the angle measurements themselves. That would be a completely different question. By the way, if you type in the sine of A, where A is 60, so if you type in your calculator the sine of 60 is equal to the cosine of 30, they are the same number. And if you type in the sine of 70, you're going to get the cosine of 20 degrees. If you type those two numbers in, you're going to get the same answer. So that's what confused a lot of people. I saw a lot of confusion with that question in the context that I just showed you. But this is your answer. That's what they were looking for in the first place. That, did you know that the sine of A equals the cosine of B? And if you did, then you got this question right. All right, moving on to number 28. So this is the area of a sector question. Very typical question on this exam. It's on every exam, actually. It says here, in the diagram below, the circle has a radius of 25 inches, and the area of the unshaded sector is 500 pi inches squared. Determine, state the degree measure of angle Q, the central angle of the shaded sector. So there's a lot of information that they're giving you here. First of all, the area of the unshaded sector is 500 pi. Okay, so you're trying to find the state try to find and state the degree measure of the shaded sector. So let's go ahead and break down this problem just a little bit. We want to find, okay, since we're given the radius and the area of the unshaded sector, since we're given two components of this formula, we could actually find the angle which is inside of the unshaded sector. We're not solving for the angle Q yet. We're solving for the rest of the angle of the circle. So you should know by now that the area of a sector, any sector, is n over 360 pi r squared. Or it could be pi r squared, no, I'm sorry, 1 half r squared theta. That's the other formula. But honestly, this is probably the better of the two to use. So the area of this case of the unshaded sector is n over 360 pi r squared. Again, it's still a sector. It's the same formula. So they tell us that the area is 500 pi. Plug it in. 500 pi. That is equal to n. Now n is the degree measure of this. We don't know what it is though. So it's n over 360 pi times the radius. The radius is 25. And you square it. So now let's go ahead and solve for n. Again, you just from a previous example on this exam, multiple choice somewhere, you have to know how to multiply by reciprocals. So 360 is in the numerator, you move it up, the denominator, you move it up to the numerator. And you are dividing by what's in the numerator, so you move it down to the denominator. So this is pi and then 25 squared. Keep n alone, don't touch it. We're trying to solve for n. Okay? When you do one side of the equation, you must do to the other side of the equation. It looks messy, but it's really not that bad. Okay. These cancel. Pi's cancel, and the 360 cancels. So now we're just left with n on this side. So n is equal to something. So if we type this into our calculator, we have 500 pi times the reciprocal of the right-hand side of that equals sign. So it's 360 divided by pi times 25 squared. Your answer is 288. So n is equal to 288. But that's not our answer that we're looking for. This is 288 degrees. We're trying to solve for the measure of angle Q. Well, there's 360 degrees in a circle. That's the angle of the unshaded sector. In a circle, there's 360 degrees. So all you do is you just take 360 minus the 288. That equals 72 degrees. Ladies and gentlemen, the measure of angle Q is equal to 72 degrees. That is the answer to this question. Okay? So that was just a little key component that you just had to remember, that you were solving for the shaded sector, not the unshaded sector. All right, moving on to question number 29. I don't know why density is in geometry. I just don't. But it is. So let's go ahead and solve this. A machinist creates a solid steel part for a wind turbine engine. The part has a volume of 1,015 cubic centimeters. Steel can be purchased for 29 cents per kilogram. It has a density of 7.95 grams per cubic centimeter. If the machinist makes 500 of these parts, what is the cost of the steel to the nearest dollar? So immediately when I'm reading through this, and you should see it too, it says steel can be purchased for 29 cents per kilogram. Oh, what do they decide to do? Oh, okay, yeah. The density is grams per cubic centimeter. Kilograms and grams are not the same unit of measure. Well, actually, okay. They are the same unit of measure. They're both grams, but they're different decimal places. Okay? It's everything that you learned in science class applies to now. So, I hope that you remember from science class the acronym King Henry drinks ultra dark chocolate milk. That's a conversion of everything. The K over here, this is kilograms, and the U stands for the unit of what is given. In this case, the unit is grams, so grams should go there, and you should be moving the decimal place back and forth. We'll do that later, okay? So we need to figure out what the question's asking us. If the machinist makes 500 of these parts, what is the cost? So we're trying to find a dollar amount. So there's a whole bunch of stuff here. Volume, density, everything. What do we do? Okay, well, let's break it down step by step. So the volume, they tell us that the volume is 1,015 cubic centimeters, and that the density is 7.95 grams per cubic centimeter, okay? So we need to find the weight of this material. We need to find the weight of this material because it's 29 cents per kilogram. That's a unit of weight, how heavy it is. And we're trying to find the cost of the weight of it, right? I mean, when have you ever gone to a supermarket, honestly? When have you ever gone to a supermarket and purchased a banana and they calculated the volume of that banana? No, they calculate the weight of the banana, right? So you're trying to solve for weight. The formula that you should know to calculate for weight is that weight is equal to density times the volume. Well, that's good information that we have because we have volume and the density. So let's go ahead and plug this in. So the weight is equal to 795 grams, and the volume is also in cubic centimeters, and everything matches so far. So far we have grams, cubic centimeters. We're good. We're not breaking any rules. So it's just 7.95 times 1,015. When you plug this into your calculator, you get the weight is 8,069.25 grams. That's the weight of the material, okay? So now what we're going to do is we're going to take this amount of grams and we're going to multiply it by 500 because that's how many parts they need. So it's simply 8,069.25 multiplied by 500, where these are the parts that we need. So these are the parts, and this is in grams. When you plug that into your calculator, you get 4,034,625 grams. That is the amount of weight of all the parts combined in grams. But it's asking you for kilograms, right? So what we need to do is we need to take this number and properly convert it into kilograms. So all you do is you take 4,034,625, and you're taking the decimal place and you're moving it 3 places to the left. So in kilograms, it's 4,034.625 kilograms, okay? So that is the proper unit of measure so far. Now what do we need to do? Well, we're trying to find the cost of the whole thing. Multiply this by 0.29 because it's in kilograms and the cost is in kilograms. So multiply this by 0.29 or 29 cents. And when you plug that in, that gives you an amount of 1,170.041. That's in dollars. So we just found the physical dollar amounts. So in order to round it to the nearest whole dollar, that's just $1,170. That's the answer to that question. Again, just have to know weight, density, volume, all that other stuff. Don't know why it's in geometry, but it is what it is. Number 30. Okay, so this one was a tricky question, in my opinion, because you have to be very careful on what you were looking at. It says, in the graph below, triangle ABC has the coordinates -9, 2, -6, 6, and -3, 2. And triangle RST has the coordinates -2, 9, 5, 6, and 2, 3. It's saying here, is triangle ABC congruent to triangle RST? Use the properties of rigid motions to explain your reasoning. So, listen, I know that eyeballing is so not everyone's thing, but just by looking at this, to me personally, it looks as if that BC is larger than ST. It does. Slightly, but it does. So what I would recommend for you to do is to do two things. I actually proved it by two things. I used the distance formula on these two sides to prove that they're not congruent, and I used a rule of the reflection over the line y equals negative x, because, again, if you eyeball it just a little bit, you could somewhat tell that these triangles are actually reflected over the line y equals negative x if they were congruent. So are they congruent? I'm going to show you if they are or if they aren't. They're not. So let's go ahead and prove that right now. I'm going to use the distance on the length of BC and the distance on the length of TS. So let's go and do that right now. I need a pen. Okay, so the distance of BC. Now the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now the point B, they tell us all this, every number that I'm going to plug into the formula I got from the instructions that they gave us, or the background information. So the distance of BC is equal to the square root of -6 minus -3 squared, that will eventually become a positive, plus -6 minus a -2 quantity squared. So further simplifying this problem, we get -6 plus 3, so that gives us a -3 quantity squared, plus, let's see, there's going to be -4 quantity squared. So the distance is the square root of 3 squared, which is 9, sorry, -3 squared, which is 9, plus -4 squared, which is 16. That gives us the square root of 25, which is equal to the number 5. So the distance of BC is 5. Now we're trying to solve for the length of ST. So let's go ahead and do that now. So the distance of ST is equal to the square root of 5 minus 2 squared plus 6 minus 3 squared. That equals the square root of 3 squared plus 3 squared, which is the square root of 9 plus 9 is equal to the square root of 18. Well, the square root of 18 simplifies to 3 radical 2. 3 radical 2 is not the same thing as 5. So we just actually proved that those two sides are not congruent to each other. So far, triangle ABC is not congruent to triangle RST. I just proved you that. But let's just say hypothetically that you made a mistake. You know, we're all human, but I didn't make a mistake. But let's just say you did. What I would do then is, I actually did this on my paper. I just said before, looks like a reflection over the line y equals negative x. How would you use the rule? Let's use transformations to prove it too, right? So the transformation rule, given the point xy, and you're trying to reflect it over the line y equals negative x, well, the rule is, if you reflect it over the line y equals negative x, the coordinate that you get is negative y negative x. Well, let's go ahead and do that right now. The points listed of A, B, and C is the point -9, 2, -6, -6, and -3, -2. Well, do this. The reflection over the line y equals negative x, you should yield the result of negative y negative x. Okay, let's try A prime, B prime, C prime. I'm not going to use the same letters, but A prime, B prime, C prime. You switch and negate. So you should be getting -2, 9, 6, -6, and you get 2, 3. Now, I want you to compare these points to the given points of triangle RST. Well, this is going to be the point R, this is S, this is T. Compare it to what's given above. Well, -2, 9. Okay, that's good. 6, -6. Uh-oh. 5, 6. Not 6, -6. So that's... Oh, I'm sorry. That should be a positive 6. My apologies. That should be a positive 6. But it's still... That's 6, 6. It shows 5, 6. That doesn't make any sense. It doesn't make any sense. It's off by 1 unit. So we know for sure that these two triangles are actually not congruent to each other. So we need to somehow put these into words, right? I'm going to shrink this down so I have a lot more room, because that is quite important for me to have as much room as possible. Let me zoom out here. Bear with me for a brief moment. I need to group all this stuff and shrink it down. Thank you. Okay. Perfect. So I'm going to move this up here for now. Okay. So we need to prove it with words. Let's do it. So use properties of rigid motion to explain your answer. So your answer, first of all, is triangle ABC is not congruent to triangle RST. Because there is no rigid motion. There is no rigid motion that maps these triangles onto each other. Right? The reflection over the line y equals negative x fails. And the length of BC is not congruent to the length of TS by the distance formula. So that's not congruent at all. It fails both the reflection over the line y equals negative x and BC is not congruent to TS, right? So that's why they are not congruent, and I just proved it to you using those rules. All right, moving on to number 31. Bob places an 18-foot ladder 6 feet from the base of his house and leans it up against the side of his house. Find to the nearest degree the measure of the angle the bottom of the ladder makes with the ground. So we're talking about a house. You could draw a house if you want to. You don't have to. I very rarely draw a house. So we're talking about a length of a ladder, which is it's an 18-foot ladder, and it is 6 feet from the base of his house. So this is 18 feet, and this is 6 feet from his house. We're trying to find the angle that it makes with the ground. So again, this is a classic SOHCAHTOA question. So now what we're going to do is figure out which function to use. Which trigonometric function are we going to use? Sine, cosine, and tangent. Well, the 6 is your adjacent. The 18 is your hypotenuse, I should say. Because that's your right angle. And remember, across from the right angle is the hypotenuse. So we're using the hypotenuse and we're using the adjacent. The only one that would work is cosine. So we have the cosine of some angle x is equal to the opposite, which is 6, over the adjacent. No, I'm sorry. Why do I keep saying opposite? It's the adjacent, which is 6, over the hypotenuse, which is 18. Now, to solve for an angle measurement, you actually need to use cosine inverse of 6/18. So we're trying to solve for the cosine inverse of 6/18. So go to trig, click on cosine inverse of 6/18. Your answer is 70.5. So x is approximately equal to 70.5. You're asked to round it to the nearest degree. So x is equal to 71 degrees. That, ladies and gentlemen, is how you do that question. Not too bad. Moving on to number 32. These are now the part 3s, and they're a little bit more challenging. And this one requires kind of a lot of work, and they don't give you much room on your paper. So it says here, triangle ABC and triangle ADE are graphed on the set of axes below. Describe a transformation that would map triangle ABC onto triangle ADE. So you're going from a small triangle to a big triangle. Okay, so that's important information so far. And it says describe. It says describe, so that's also very important too. So when it says describe, that means you need to state the scale factor. That means that you have to describe where it's coming from, what's the point of, or the center of dilation. You need to give all that information, right? So what I'm going to do is on the side over here, I'm going to list all the points. So point A is -9, -8. Point B is the point -8, -4. It's very important that you do list these points because we will be using the distance formula momentarily. -6, 4. Okay. So now we're trying to find the scale factor. We know for sure it's a dilation, right? We know it's getting bigger. So what I want to do is I want to find the distance of AC, and I want to find the distance of AE. Find the scale factor, write it down, and describe. So let's, in order to do this, we could only use one thing, the distance formula. So we have to use the distance formula to get this right. So we're going to find the distance of the line segment AC. That is equal to the square root. Now, all of these numbers that I'm putting in here come from all these points. So this is the point. Let's see. We're doing x's first. So negative 9 minus a negative 5 squared. Plus, I need to move this over. This is nice. Come on. Okay. Bear with me here because it's a pain in the neck to write this stuff down. So negative 9 minus a negative 5 squared plus negative 8 minus a negative 6 quantity squared. That is equal to the square root of negative 4 squared plus negative 2 squared. That equals the square root of 16 plus 4, which is the square root of 20. Now, just for the heck of it, I'm actually going to break down this radical. Square root of 4, square root of 5. The square root of 4 is 2. Radical 5 carries on for the right. So that's the distance of line segment AC. So now what we need to do is find the distance of AE. Let's go ahead and do that right now. So the distance of line segment AE is equal to the square root of negative 9 minus 3 squared plus negative 8 minus a negative 2 squared. It's equal to the square root of 144 plus 36. That is the square root of 180. When you break it down, the square root of 180 breaks down into the square root of 36, and the square root of 5, the square root of 36 is 6. Radical 5 carries along for the ride. That is the distance of line segment AE. Now, folks, I want you to analyze this very, very carefully. 2 radical 5, and I'm just going to darken that a little bit, 6 radical 5. So 2 radical 5 and 6 radical 5. I hope that you know how to multiply radicals. When you multiply radicals by a constant number that is not a radical, you just multiply the outside numbers. So 2 radical 5 and 6 radical 5, take a look at this. 6 radical 5 is actually triple the amount of 2 radical 5. All you need to do is just take this number, multiply by 3, and that gives you 6 radical 5. So the distance of this is 2 radical 5. Hold on a second. This is 2 radical 5. And the whole thing is 6 radical 5. The scale factor is 3, right? If you take 6 radical 5 and divide it by 2 radical 5, the radical 5s cancel because they're like terms. 6 divided by 2 is 3. So we know that the dilation is a scale factor of 3. So we just got that done. So the scale factor, we just concluded that the scale factor is in fact 3. Now, where is this being centered from? It's centered at point A, right there, because it's extending from A. So it says describe a transformation that would map triangle ABC onto triangle DEF. Well, your answer is just going to be simply this: a dilation. We know it's a dilation with a scale factor of 3, centered at point A. Centered at point A, will map or maps triangle ABC onto triangle ADE. And that, ladies and gentlemen, is how you do that question. Now, of course, there's a follow-up because it is a part 3. Not too hard, though. The next one says, explain why this transformation makes triangle ADE similar to triangle ABC. Okay, well, it's a dilation, right? And we know this, and dilations do the following. A dilation preserves angle measure. And if you want to include this, you don't have to. And it also preserves proportionality. By using angles, so by angles, triangle ADE is similar to triangle ABC by angle, where angle A is reflexive, shown on the graph, the diagram, where A is reflexive in both triangles, and angle ACB is congruent to angle E because they are corresponding. So we just proved that they are similar by angle. That, ladies and gentlemen, is how you answer that component of the question. Okay, moving on to number 33. A storage tank is in the shape of a cylinder with a hemisphere on the top of it. The highest point of the inside of the storage tank is 13 meters above the floor of the storage tank, and the diameter inside the cylinder is 8 meters. Determine and state to the nearest cubic meter the total volume of the storage tank. So they're asking you for the volume. So what you need to do is dissect it. Dissecting meaning that you take each individual component and you find the volume of it, then add it up. So you're trying to find the volume of the hemisphere, and you're trying to find the volume of this cylinder. So how do we do it? Well, all we're doing is we're taking the volume of the hemisphere, which the volume of a hemisphere formula is actually 1/2 of 4/3 pi r cubed. It's just 1/2 of a sphere. And the volume of the cylinder is pi r squared times the height. So what are we doing here? So a couple things that we need to understand on what's shown in the picture is that the diameter is 8 meters. Well, there's also a diameter up here that's 8 meters as well. Now the radius, the length of the radius of the hemisphere and the cylinder is 4. Now here's the trick to this question. You could also draw a radius from the same center. It's still possible, right? If you have a center of a circle or even a sphere, any radius drawn from that same center, they're all congruent to each other. So this is also 4. Well, that helps us a lot, because if you just simply draw a line to the height, if this is 4 and that's 13, then the height of the cylinder is actually the number 9. 13 minus 4 is 9. So we just got all of our information. We got our radius, we got our heights of the two figures. We can now go and solve the question. So the volume of the hemisphere first. So the volume is, my apologies, the volume is 1/2 of 4/3 pi times the radius, which is 4, cubit. When you plug this into your calculator, actually, I'm not going to do that yet. I'm just going to leave it as is. And I'm going to find the volume of the cylinder. So the volume is pi r squared times the height. So the radius is still 4 squared, and the height is 9. That was the key there. The heights were challenging to get. Okay? So I'm going to add these together. I'm just doing a big addition of these two. Go to your calculator page. And I want you to type this stuff in. So we have pi times 4 squared times the height of 9 plus 1/2 of 4/3 pi times the radius of 4 and cubit. And we get 586.4. So the total volume that we have, the total volume is 586.4. It's asking you to round it to the nearest cubic meter. 4 is not upping it at all. So your volume is actually just 586 meters cubed. You do not have to put the units of measure, but I just do it anyway. Your answer is 586. Moving on to number 34. There was a typo on this exam when it was given. So if you have a book, like a physical book, like something that is a Barron's book or from the Topical Review Book Company, this typo may not have been fixed. if you go to my website and print a hard copy of the exam, this has been fixed. It just showed M on the Regents. It should be MI for miles, just to clarify. So you shouldn't be converting anything. So it says here, as shown in the diagram below, an island labeled I is due north of a marina M. A boathouse, which is labeled as H, is 4.5 miles due west from the marina. From the boathouse, the island is located at an angle of 54 degrees from the marina. Determine and state to the nearest tenth of a mile the distance from the boathouse H to the island I. So we're looking for this right here. I'm going to call that X, right? Well, the problem is we don't have two other lengths of this right triangle to help us out, because we could have just used a Pythagorean theorem. But what they want us to do first is they want us to use, again, SOHCAHTOA. Okay? So we're going to use SOHCAHTOA on this question to solve for the length of X. This is your reference angle. We have an adjacent side, and we have the hypotenuse because it's across on the right angle. So we're using an A and an H. Cosine. Great. So this is the cosine of the angle 54 degrees is equal to the adjacent, which is 4.5, over the hypotenuse, which is going to be labeled as X. Cross multiply and solve. So we get X cosine of 54 is equal to 4.5. We need to solve for X, right? So we need to divide by the cosine of 54. Divide by the cosine of 54. And we get, I don't want to draw that line, and we get X is approximately equal to whatever that number is. So if you go to your calculator, right, do control division, 4.5 divided by cosine of 54, and we get 7.65585. Okay, a whole bunch of stuff, right? So we get 7.655857. It's asking you to round it to the nearest tenth of a mile, but I'll tell you why I wrote that whole decimal in the first place. So X is equal to 7.7. Okay, so we know that for sure. Now, that's easy. That's not bad. But then they throw this on here. It's not bad either, but it says determine and state to the nearest tenth of a mile the distance from I to M. Well, that's where this is coming from. I don't want you to use 7.7 as the length of this. I want you to use this whole decimal. So this is actually 7.6555857. So you might be thinking, why are you telling us to put that down? Well, there's actually two ways you can solve this problem to solve for this length. Either you could use a Pythagorean theorem, because now you have two sides of a right triangle. You could use a squared plus b squared equals c squared. Or you could use trigonometry without using this side at all and just say, okay, this is the opposite, this is the adjacent, you're using tangent. And that could also work. But, whatever floats your boat, no pun intended. So, I'm going to use the Pythagorean theorem because I like it. So, the Pythagorean theorem. So, the Pythagorean theorem states that a squared plus b... What's wrong with my 2's? First was my 5's. Now it's my 2's. I don't know what's wrong with me. A squared plus b squared equals c squared. The length of A is 4.5. Square it. We're trying to solve for b, and we have c squared, which is 7.6555857 squared. So now I'm going to just I'm typing this into my calculator. So we have 4.5 square. We get that number, and take this number up here, copy it, and square it. So we have this number. So in your brain, you know that this is that's a squared, and this is c squared. So now what you're going to do is take this number and subtract this number, get that number, take the square root of that number, and that's your answer, which is going to be 6.19, which is really 6.2 when you round it. So, of course, I'm going to write all that out for you. I'm not just going to leave you hanging. So this is 20.25 plus b squared is equal to 58.61215.06177. I'm going to subtract this on both sides. We get b squared is equal to 38.36215.06177. Don't round until the very end. Take the square root of both sides, and you get b is equal to 6.194, which is approximately b is equal to 6.2. Ladies and gentlemen, that is the answer to this part of the question. Not a bad part. Easy stuff so far. Now, here's the part 4. Thank goodness that I don't need to do 2 of these questions, but this is it's such a joke. I'm sorry. If you don't know how to do this question, then you haven't been paying attention, because this is you better be praying for one of these on your Regents exam. Unfortunately, if it's January 2018 and you're taking like June of 2018, probably not going to happen. You're probably going to have like a real proof or something like that. But they made it easy. They like, all right, let's give these kids a break and let's give them a coordinate geometry proof. Very, very easy. Very easy. So it says, in the coordinate plane, the vertices of triangle PAD are P, -6, -1, -6, A, -4, 5, and T, 5, -2. Prove that triangle PAT is an isosceles triangle. Okay, not too bad. So here's the plan. We are going to use the distance formula, because I always like to make a plan. We're going to use the distance formula 3 times. We're going to use it 3 times to prove that there are 2 congruent sides. You have to use it. Now, you don't have to use it 3 times, but I like to use it 3 times because I don't know what sides are going to be congruent to each other. So we're going to find the distance of PA, then the distance of AT, then the distance of PT. So all these numbers that I'm getting, right from the given information. So again, the distance formula has not changed for centuries. So the distance formula is x2 minus x1 squared plus y2 minus y1 squared. The distance is going to be -1 minus -4 squared plus -6 minus 5 squared. So the distance is equal to the square root of 3 squared plus -11 squared, which is the square root of 9 plus 121, which is the square root of 130. Leave that, do yourself a favor and leave that unsimplified, okay? So that's the distance of PA. Now let's calculate the distance of AT. Okay, so the distance of AT, right? The distance of AT is the square root of 5 minus a -4 squared plus -2 minus 5 squared. The distance is the square root of 9 squared plus -7 squared, which is the square root of 81 plus 49, which is the square root of 130. Nice. Now, you could stop here if you want to, but I don't know what follow-up question that they're going to ask, but I know for sure that these are equal to each other. We just proved this to be isosceles. But what if, like, the next question they ask to prove, equilateral? Whatever. Just find the third distance. It can't hurt. So the distance of PT, that is going to be D equals the square root of 5 minus a -1 squared plus -2 minus a -6 squared. That's equal to the square root. Let's see, this is 6 squared plus 4 squared, which is equal to the square root of 36 plus 16, which is the square root of 52. They don't match, but that's okay. We just proved it to be isosceles. So we're going to say that triangle PAT is isosceles because 2 sides are congruent. Do you have to say that? Of course you do. It literally says, prove that they're congruent. You have to put a statement afterwards to show them what you're talking about. So that's true. Perfect. Now, it says, state the coordinates of R. That quadrilateral part is a parallelogram. Well, here's the thing. There's really no way to use some formula to figure out what point R is. So this is what I suggest doing, is draw your triangle on your coordinate axes, right? So point P, for example, point P is a point -1, let's see, -1, 6, -1, 2, sorry, -1, -6, 1, 2, 3, 4, 5, 6, that's the point P. A is the point -4, 5, okay, and 5, -2. This is the point P, A, and T. Okay, so now what I'm going to do is just simply draw my lines. Now, so far, this is an isosceles triangle that we know for sure about. But now what we need to prove, or sorry, not prove, we need to find the coordinates of R. So you should know, in order to prove this to be a parallelogram, that point R should be somewhere in that vicinity. Now let me tell you a couple tricks on how to do this. Point R is somewhere up here, we don't know where. But we know for sure that this line segment eventually, which is RA, has to be parallel to PT. So the best thing that you could do is to actually find the slope of line PT and then just apply it to point A. So the slope of PT is up 1, 2, 3, 4 to the right 1, 2, 3, 4, 5, 6. Don't reduce it. I'll explain. Well, not explain. You'll see why right now. Don't reduce it. Go up 4, 1, 2, 3, 4 to the right 1, 2, 3, 4, 5, 6. Hey, that looks a lot like a parallelogram, does it not? Right? So we know for sure that this is a parallelogram. I hope that's, you know what, that's a little too light. Let me get a different color. I like aqua. It's one of my favorite colors. So we know for sure that we just got the right answer. So this is point R, people. R is a 0.29. Write it down. You were done. You don't even need to justify it. Just write down the point R29. You're done. Move on. Now it says, prove that quadrilateral PART is in fact a parallelogram. So, in order to prove something to be a parallelogram, how about we just prove the opposite sides to be congruent? Well, newsflash, we just proved that PA is congruent to AT. Oh, wait a minute. Didn't Trevor just say to find the distance of all three sides? Oh, you bet. Because the reason why is I just saved you a step from the next part. Because we just found the distance of PT and AP. And we also found the distance of AT, but we don't need AT. But we need to now find the distance of RT and AR. Now, once we find the distance of AR and RT, we can compare those to the distances that we found for the isosceles triangle. So let's go ahead and do that. We need to find the distances of those two sides to prove opposite sides are congruent in a parallelogram. So let's do it right now. We're going to find the distance of TR, which is a square root of 5 minus 2 squared plus negative 2 minus 9 squared. Again, these are just numbers that I know from my graph. Square root of 9 plus 121, which is the square root of 30. Oh, that's nice. Which we know that the square root of 130 is equal to the distance of PA, which we found before, which is equal to the distance of TR. Hey, that's perfect so far, right? We're good so far. So we have the distance. Now for the next part, the distance of AR. The distance of AR is equal to the square root of negative 4 minus 2 squared plus 5 minus 9 squared, which is the square root of 36 plus 16, which is the square root of 52. Hey, the square root of 52 is equal to the distance of PT, which is equal to the distance of AR. So that we know, and we just proved that opposite sides are congruent. So now we're going to say that. I need to draw that better. So here we go. So since this quadrilateral, PART, it's an ugly R, PART has two pairs of opposite sides that are congruent to each other. Quadrilateral part is a parallelogram. And we just proved it. Sweet. And that, ladies and gentlemen, is how you do that part of the question. Not too bad. You just had to say that opposite sides are congruent to prove a parallelogram. Done. Okay. that is the conclusion of this video. I hope that it helped you. Make sure to hit that subscribe button down below. Consider becoming a patron on my Patreon page. I would truly, greatly appreciate it if you would consider doing that. You could throw literally $1 at me, and that is all I need to keep this channel going for many years to come. And make sure that you visit my website at www.nysmathregentsprep.com for more math content and geometry and all of your future mathematical subjects. My website's getting bigger by the day. Not bragging, but it's true. I want to help everyone across New York State and eventually the country. If you will stick around for higher level math, maybe like AP Calculus, you might see that stuff within the next few years from this release date. And that's about all the time I have. I hope to see you soon.